अडचणी माझ्या मागे लागल्या. एक वेळ मोबाईल कडे.
So last time we had started the method for finding out inverse Y transform. So in finding out inverse Y transform, we discussed that there may be a higher level of comfort in finding derivative than that of finding integration. Therefore, a very simple and systematic way has been provided for finding out integration, that is integration by inspection. Means we have with us a table wherein the various functions and the derivatives are written. So whenever a function is given for integration, we just check it of which function is the derivative. Therefore, integration of that function means if gx is the derivative of fx, then integration of gx is fx. We do not take any effort in finding out the integration. Similarly, finding out inverse of Y transform is somewhat difficult as compared to finding out Y transform. Means the formula for Y transform is very simple, that is x of n y raised to minus n summation n ranging from minus infinity to infinity. So it is x of y. Now simultaneously, when we make our comfort level more by giving the method of inspection and try to simplify the given function of y such that it becomes a sum of some easy functions of which we know inverse Y transform. That is the simple most way of finding out Y transform. But at the same time, you should take up the issue and prepare before the next lecture the technique for finding out inverse Y transform by a systematic method. It's not a systematic method, it's just a very crude method of just trying to fit the given thing into such a form that which is the transform of something, so it's inverse. So you will, I hope that the thing that we give, we are having x of y is equal to summation n equal to minus infinity to infinity x of n y raised to minus n, and for that, so when x of y is given something, so when it works out to be some formula, it is maybe say 1/1 minus ay inverse, maybe. For that, a condition of ROC is given. A condition in which this x of y is this, a condition of ROC is given. So with this, you must be in a position to find the inverse. With this, you must be in a position to find the inverse. How it can be. So, what way you will think? Let us spend some time, let us open the problem with some hints and come to the solution. So, anybody, any idea?
No idea.
Rather than finding out inverse by inspection. Finding out inverse by inspection is just a reverse process. So that is most simple. But not knowing it, how we can find it by systematic method. What should be the systematic approach for finding out inverse by inspection? What should be the approach? Let us take various cases and by case to case basis. Actually, there are some properties of Y transform which are so obvious properties that we don't consider them. That is linear, means if I am having x1n, I have another x2n, then if I am having x1n, one function, x2n another function, then if x1y is y transform of first function and x2y is y transform of second function, then y transform of ax1n plus bx2n is equal to ax1y plus bx2y, where a and b are constant, and region of convergence is the intersection of region of convergences of both the transforms individually. It is a property of linearity. It is being very obvious. We have not just studied it as a property as such. So that is presumed. So with this, we can go for finding out inverse y transforms of some obvious expressions. Let us say, if x of y given, if x of y given is directly representable as summation of powers of y inverse or y for that matter. If x of y is expressed as a summation of direct powers of y, in that case, a computing of xn is very simple. How? Let us say, take an example. See what we are doing now? There are various methods. First is inspection, which I am not agreeing to be a method as such, but other than that, we can just come for something, and then leaving some part as a homework, we may discuss today some obvious examples which do not require the systematic formulation, but we can work with the brute force method of inspection method. So, x of y, if it is expressible as summation of powers of y, or actually to be precise, y inverse. Let us say for time being, if x of y is equal to 3y square plus 2y plus 5 plus 2y inverse plus 5y raised to minus 2 plus 6y raised to minus 3. If x of y is this, then what would be x of n? What would be x of n? It would be 3, 2, 5, 2, 5, 6. And so x of 0 is 5, x of minus 1 is 2, x of minus 2 is 3, x of 1 is 2, x of 2 is 5, x of 3 is 3. Is it clear? Because x of y is summation of x of n y raised to minus n. X of n y raised to minus n. So that infinite summation, if it is of infinite terms, then it may remain as infinite summation, or it may converge to a simple formula, Right? So I hope that it is quite clear, since it is summation of some power, and since x of n is the coefficient of corresponding power of y, that is y raised to minus n, we can find by looking at the power. It is 2, means x of minus 2 is 3. X of, it is y raised to 1, means x of minus 1 is 2. It is y raised to 0, so x of 0 is 5, and so on. So it is, I think, quite clear. Here ROC is not expressed specifically, but it should